lesson 9. So as usual, you're looking for the tasks to complete for U3L9, either under assignments or on the Canvas homepage on today's date. Today's is the 8th of December. We'll start off with a little chat in breakout rooms. Today's question is, what's your favorite family tradition? Now, this is open to interpretation. So what's your favorite family tradition? It could be just a meal that you do during the week, like maybe every weekend you do something, or it could be something you do for Halloween or Christmas or Thanksgiving or whatever other holiday or religious thing you might do. It could be that you watch a movie on Friday nights. It could be you celebrate your pets in some way, whatever, something especially you do for someone's birthday, whatever you want to share. So think about that. And remember to say hi and check in with the person you're in the room with as well. We'll come back together in 2 minutes. Rooms are open. Buddy? Next on the docket, as usual, is homework review. It was mostly actually classwork that you just had to make sure you finished up. Things are looking good, though. I'm seeing 12 attempts on the classwork that was just all those ed puzzles about the Can Crush. And then the classwork where you were working along with me in the slides, also seeing 12 attempts on that. And then the actual homework, which was a other shorter ed puzzle along with like a little quiz to complete, seeing 9 attempts on that. So again, if you haven't had a chance to tackle that yet, please do so and submit it. And remember, I think there's an alternative Google form for this one if you weren't able to do that. Any questions or comments on that homework assignment? Alrighty, let's see how we're feeling about gas properties and Boyle's law in particular. Play a little Kahoot here that I put together. It's just 8 questions. All right, game code is really long, 2935831. Please use your name or something close to it. The join code is usually on the bottom or the upper left of the screen. Here we go. Gases are blank, meaning their volume can be decreased under pressure. Very good. Almost all of you got that. That means compressible. Harmony in the lead. Kilopascals, atmospheres, and millimeters of mercury are all units of what? Very good. A little more torn on this one, but it is pressure. It's not volume. Volume is usually something like liters or milliliters, that kind of thing. All right, Nathan in the lead. Increasing the kinetic energy of gas particles, making them move faster, means you what? Very good. It means you increased the temperature. Remember, temperature is a measure of the average kinetic energy. Would not decrease pressure. In fact, it would actually increase the pressure. That's another one of the gas laws we're going to touch on today. Abby pulling into the lead now. Okay, true, false. If you increase the pressure on a gas, its volume will also increase. You increase the pressure, you also increase the volume. Very good. Looks like we're feeling good about Boyle's law. That is false, right? Boyle discovered that they have an inverse relationship. If you were to increase the pressure on a gas, you would decrease the volume. All right, Abby's still in the lead. Halfway through. Which law states that at constant temperature, gas pressure is inversely proportional to gas volume? So this is what we were just talking about in the previous question. Inverse relationship between pressure and volume. Very good. Most of you understand that's Boyle's law. We're going to explore Charles' law and Gay-Lussac's law today. Does anyone know what Murphy's law is? Anyone want to guess?
Isn't it everything that can go wrong will go wrong?
Very good. Yes, indeed. Well said. All right, Abby's still in the lead. Bob Gardner's air balloon was small when it left the ground, but really big at 39,000 feet. Why? Why did his balloon get bigger as he rose higher? Good. Again, most of you got that it decreased the atmospheric pressure, right? The higher you go, the less air pressure there is, and therefore the volume increased in the balloon. He didn't pump any more air into it. And so the same amount of gas when he started as when he was higher up, it just expanded in volume because there was less atmospheric pressure around it. All right, Abby in the lead and on fire. Okay, true, false, second to last question. In the equation P1 V1 equals P2 V2, P1 and P2 can be any unit as long as they match. Very good, that is true, right? You can use kilopascals as long as P1 and P2 are both in kilopascals, and so on. We'll see that temperature is a little less lenient. Temperature always has to be in Kelvin. All right, last question, here we go. Gas pressure and gas volume are inversely proportional. If you double the pressure on a gas, then what happens to the volume? Very good. Again, most of you got that it will be reduced by half. This is where you kind of have to put your math hats on a bit, right? That by doubling the pressure, that means times 2. So if it's inverse relationship, then the volume is going to be divided by 2 or reduced by half. All right, way to go, Abby, Clarence, and Valen. Okay, and it looks like, again, most of you answered questions correctly, so feeling good there. All right, any questions or comments on that Kahoot? All right, my goal today is to, again, use Edpuzzles with some practice problems to review Boyle's law stuff, just because I kind of feel like I blitzed through it in our previous class, and then introduce the next 2 laws, which are Charles and Gay-Lussac's laws. And so I'll provide about 10 minutes to work through each of these, and then we'll check in and I'll show you some real world examples of each. But on the tasks to complete list, you just need to start right where we were on step 3 with Boyle's Law Edpuzzle. It's about 7 minutes long with 3 questions. I'll check in after 10 minutes, and then whenever you're done with that, move on to the Charles Law Edpuzzle, and then move on to Gay-Lussac's Law Edpuzzle. I have links to the slides and the actual video as well if you just want to check those out, but the Edpuzzle is what you should work through. I'll be here listening if you have questions, if you're not sure what to do, but otherwise, I'm going to time for 10 minutes so that you work through the Boyle's Law Edpuzzle. So start with that one, Boyle's Law Edpuzzle. Go for it. All right, I'm hoping that was mostly review at this point, right? We have been talking about Boyle's Law and the general, like, don't get too lost in the math, all right? I mean, it's good to get good practice with the math. The only trick with the math is making sure that your units match, right? So don't get thrown off by that if we throw you a curveball there. And just being comfortable with algebra and fractions, and I give you more practice with that if you need. But the important thing about Boyle's Law is the relationship between pressure and volume. Remind me, did he discover that it was it inverse or directly proportional, pressure and volume?
Inverse.
Very good. They do the opposite of each other. Okay, that's the takeaway. So let's look at a real world example. You have Boyle's Law to thank for your ability to breathe. Short video we'll watch.
In order to understand the mechanisms of breathing, it's important to understand the relationship between pressure and volume. This is explained through Boyle's Law, which states that the pressure of a gas in a closed container is inversely proportional to the volume of the container. What do we mean by this? If the size of the closed container is decreased, the pressure of the gas inside the container increases, and that if the size of the container increases, the pressure of the gas inside the container decreases. Imagine a gas, shown here as blue molecules, inside a cylinder with a movable piston and a pressure gauge. If the piston is pushed down, the available space inside the cylinder is reduced, which compresses the gas. This means that the same number of gas molecules have less space to move around in, with the effect that they strike the walls of the cylinder with more frequency. If you observe the pressure gauge, you'll see that the pressure doubles as the volume is reduced to half. Conversely, if the piston is pulled up, the available space inside the cylinder is increased. This means that the gas molecules have more space to move around in, with the effect that they strike the walls of the cylinder with less frequency. In this case, as the volume doubles, the pressure is reduced to half. And it's these differences in pressure caused by changes in lung volume that allow us to breathe.
All right, so I just thought that was kind of a helpful animation. All right, everyone take a deep breath in right now, please, and breathe out. Does anyone know the muscle in your chest that you use to breathe? I don't know what that's called. Nathan?
The diaphragm.
Very good. You have a huge muscle, splits your chest in two. And the way you breathe is the diaphragm just forces your lungs to expand, right? It contracts and it makes your lungs bigger. Now, that increases the volume, which means the pressure inside your lungs decreases, and therefore air comes rushing in through your nose and mouth. That's what allows you to breathe in. And then when you breathe out, the diaphragm just relaxes, right? Your lungs spring back into their smaller shape. That increases the pressure, right? So volume decreases, pressure increases inside, and you force all the air out of your nose and mouth. And that's how we breathe. This is also why lung punctures are really dangerous, right? Gunshot wounds and stab wounds to the chest in particular, if they puncture that pleural space, your lung can collapse and you won't be able to breathe anymore because your diaphragm can't get it to expand. And so anyway, if you're curious about more of that, we cover a lot of that in my anatomy and physiology class. It's kind of fascinating. So, all right, any questions or comments on Boyle's Law? All right, I'm going to put 10 minutes on the clock again. You can either finish up the Boyle's Law Edpuzzle or move on to the next one, which is Charles's Law. Again, let me know if you have questions. When you take a balloon filled with, and I think it's just air, and put it in an incredibly cold liquid, like with liquid nitrogen, the volume decreases, right? So there's that directly proportional relationship. Temperature down, volume of a gas down. And so that's why the balloons basically, he was able to pack all four of those balloons into that tiny container. And then when he took them out, I think it's kind of cool. They almost look like they're alive, but the gas is warming up again, temperature is increasing, and therefore the volume of the gas increases and the balloons reinflate. And they literally went right back to the way they looked before. So that's a demonstration, again, of Charles's law. Any questions or comments on that? All right, we only have a few minutes left, but I'm just going to go ahead and time for 6 more minutes to either continue on to Gay-Lussac's law or just finish up whichever video you're on. For it.